Horizontal component, just easy, should be 12 times cos 50. Vertical component would be 12 times sine 50. Maximum height reached, you consider the vertical motion only. At maximum height, the final velocity would be 0. From there, you would have found the value of the vertical displacement, which should be 4.3, also known as the maximum height. H max equals to 4.3 meters. Let's move on to the last part, which is the most important one for 4 marks. Determine the magnitude of the displacement PQ. If I get back to the diagram, the displacement PQ would be this one, from here to here, this one. Since it is a question of projectile motion, so we always break down the projectile motion into horizontal and vertical parts. So I need this displacement, or you can say distance is in a straight line. Distance and displacement would be then same. And I need this one pathway. So I need this vector and I need this vector. Then I can have the displacement from P to Q. We already found the maximum height in the previous part, which was 4.3. So the value of this thing is 4.3 meters. Only if I know the horizontal displacement, then I can use the Pythagoras theorem and I can find the value of the displacement from P to Q. But then the big question is, how do we find the value of the horizontal displacement? Well, we need to use the formula of the horizontal motion, which is, we have only a single equation for the horizontal motion. Displacement equals to velocity into time. So do I have the initial horizontal velocity? I do have it. So the horizontal velocity is 7.7. But then, how long does the ball take to travel from P to Q? I don't know the value of t. But one thing that we know is time is same for vertical as well as horizontal motion. So if I could find the value of t from the vertical motion, I can use that value of t over here. So let me first find the value of t. So since t is unknown, we first find t. Through vertical motion. So generally, in order to find t, you use this equation, s equals to ut plus 1 over 2 at square. And be careful with the sign convention. This is the reference point. You started off with this one. If you're above the reference point, your displacement would be positive. In this case, should be 4.3 with the positive sign. And then do we have the initial velocity? Yes, we do have the initial velocity. And the initial velocity is not 0, by the way. Or matter of fact, we are provided with the initial velocity, so why don't I use the very first one? It would be even easier if I could use the first one. U plus at. V equals to u plus at. I can first rearrange it for t. V minus u divided by a. What do we have then? The final velocity at the point Q, the final vertical velocity would be 0. because this equation is for the vertical motion. Minus, what is the initial vertical velocity? Could you give me the value of initial vertical component of velocity? The answer of this one? 9.2. Okay, so 9.2 from here divided by the value of a, which in according to the sign convention for the equations of motion of free fall, we take it as 9.81 but with the negative sign. Now these two negative signs would be cancelled out and the value of t would be 9.2 divided by 9.81. And if I could do it on the calculator, we into SF we get 0.94. Now from the vertical motion, or using the vertical motion or vertical motion analysis, I have found how long does it take for the ball to travel from P to Q vertically. The same time would be taken for the ball to travel horizontally. So I can use the value of t and I can insert in this equation. Now S equals to, the value of V was 7.7, we had it already, and time would now be 0.94. So if I hit it on the calculator, 7.24, okay, meters. What is this displacement? This is the horizontal displacement. 7.24 meters is your horizontal displacement. Now you have the value of the base of the triangle and you have the value of the perpendicular of the triangle. You need to find the hypotenuse. You can use the Pythagoras theorem and you can easily find the value of hypotenuse. How do we do? So that displacement from P to Q equals to 7.24 square plus 4.3 square divided and then square root of all of it. So if you could hit it on the calculator as it is. I told you the answer of this one, we have 8.4 as the answer of this one. So once again you can see clearly the question is for 4 marks and that's why you had to do a lot of steps and you need to consider both the motions, the vertical motion and horizontal motion. And matter of fact, time is a quantity which is same for both of them. If you could find the value of time from the horizontal motion, you can place the value of time in vertical. But generally what happens is you have to find the value of t, the value of time from the vertical motion. So usually in the question that you have, the value of t has to be found through the vertical motion and then you place it in the horizontal motion equation. All right. So this is the second case, and the most important property once again of the second case is the initial vertical component of the velocity is 0. So we need to find the velocity as it leaves the table. The velocity of the ball of mass 0.45 kilogram as it leaves the table. We need to find this value in this question. We need to find the value of v. So horizontal velocity needs to be found out. So if we need to find the horizontal velocity, I have to consider the horizontal motion. So I'll give the heading here first, horizontal motion. And I know only a single equation for horizontal motion, that displacement equals to velocity into time, and velocity could then be written as displacement over time. I'll quickly insert the values because I do have the value of the horizontal displacement, which is 1.50. So I'll write over here 1.50 divided by the time it takes for the ball to go from here to here. So you could take the time from the horizontal motion or from the vertical motion. Now you can't do anything through the horizontal motion because if you want to find the value of t, you only have one equation. So if you need to find the value of t, then these two things must be given. But the problem is the value of v is also unknown. So you have two unknown quantities here. So what we do is we knock at the door of the vertical motion and we ask for the help from the vertical motion. And the vertical motion gives us one of the equation and it says I can assist you by giving this equation only and the rest is to be done by you. And matter of fact, for vertical motion, how many equations do we have? Four, all four that we use for equations of motion. But as the vertical motion gives us the equations, he also says that be careful with the sign convention. It says, okay, you can use this equation of mine, but you gotta be careful with the sign convention. Now, what is our reference point? What was the starting? The reference point was here. Then the ball goes below the reference point, hence the displacement would be negative. So value of s would be 1.25. Initial vertical component of the velocity is 0, so the entire thing would be reduced to 0. This whole thing would be 0. 1 over 2 as it is, we had negative sign with this. 1 over 2 as it is, a would be minus 9.81. T square as it is. Then we quickly do some cancellation here. Negative sign cancelled out. And what we do is t square equals 2 times 1.25 divided by 9.81. And whatever the answer is, we take square root of it. So could you hit it on the calculator first and then take square root of it and give me the value of t? So I can use this value of t and I can place it all the way over here. So I'll be very quick with it before this value of t disappears. So 1.50 divided by this thing. Do it. Okay, 2.97. You can write it as it is, or in 2SF you can write it as 3.0. Okay, then the next part is you gotta find the velocity just as it hits the floor. So which velocity are they asking? Are they asking for the horizontal velocity or are they asking for the vertical velocity? The answer is they haven't specified, so that means the resultant velocity. And how do you find the resultant velocity when two velocities are given? This is the expression, the resultant vector. square of x component and square of y component. And like I said, the horizontal velocity remains same everywhere, so you have the value of Vx, which is 2.97 meter per second. But the only problem is you don't have the value of Vy. The value of the vertical component of the velocity at the start was 0. It increases over here, it increases further over here, increases even more here, increases even more here, and just before it hits the table or the floor, the value of the vertical component of the velocity would be maximum. But how much would that be? Answer is we don't know, but we can find it. So if I want to find the velocity, the vertical component of velocity as it touches the floor or just before it touches the floor, what if I use this equation? The last one. So this is also given in the formula sheet, and the previous one is also given in the formula sheet. It's just a matter of finding the right equation depending on what kind of data do you have. I need to find the now this is for the vertical motion, and whenever we use these equations of motion for free fall, we gotta be careful with the sign convention also. Now v square would be written as it is. I know my value of v should be negative because at this point the vertical component of the velocity should be downward. So if we follow the sign convention, our answer should be negative. So u square. Or if we use, let's say if we can use this one also, v equals to u plus a t. Do we have the value of t? Do we know how long does it take for the ball to reach here? 0.504 seconds. So the value of t is given. Do we have the value of u, the initial vertical velocity? Yes, we do have. So let me write down the equation here. Let me insert the values. U would be 0. Initial vertical component of the velocity was 0. A would be minus 9.81. And the value of time would be how long does it take for the ball to go from here to the floor. It takes the ball as it hits the floor, it takes it 0.504 seconds. 0.504 seconds. Alright, then you can get rid of the 0 and you gotta hit this thing on the calculator. Can you do it for me? You see, your answer should be negative, and it is already going very well with the sign convention, and a big sigh of relief to see that the velocity, the answer of velocity is negative, because according to the sign convention the velocity is downward, so it should be negative. So what is the value that we have? Okay, if you say so, negative 4.9 meter per second. So this is the vertical component of the velocity just as the ball hits the floor, hits the ground. The horizontal component of the velocity just as the ball hits the ground was 2.97, and the vertical we just found is minus 4.9. Minus 4.9 meter per second. Now we have the horizontal component, we have the vertical component, we need to find the velocity, which means we need to find the resultant velocity. I can safely use the Pythagoras theorem. Square of it plus minus 4.9, square of the entire thing. The minus is within the square. So what do we get? V equals to what? Just write it as it is on the calculator. How much? Can you give me 3SF? 5.67. Okay, so we can write it as 5.67, or you can also write it as 5.7. But since all the values were in 3SF, so I'll go with 3SF. So this is the magnitude of the velocity as the ball hits the floor. And what velocity is this? You see, there are two components of the velocity that we found already previously. One of the component was over here, the horizontal component. I'll draw the exaggerated vectors. One of them was over here. One of them would be downward. And the one that we have found is the resultant of these two. The one we have just found is the resultant of these two. So I'll draw the same diagram over here also. The the horizontal one, and we have the vertical one, and then we had the resultant of these two. So something like this. So vertical one was 4.9, the horizontal one was 2.97. I'm writing the magnitudes only. That's why I'm now writing the negative sign. And the resultant one was 5.97. Now the next part, you need to find the angle to the horizontal. Of what? Of the velocity. The angle of the velocity means the angle of this thing with respect to the horizontal. This is the horizontal and this is the velocity, means they are asking you to find the angle over here, this angle theta. So what you can do is, instead of drawing this vector over here, you can draw it exactly on the right side, 4.9, and now you get a right angle triangle. This is the angle theta. This one would be perpendicular, this one would be base. You can use tan theta. So tan theta equals to perpendicular divided by base, then theta equals to tan inverse of this whole thing. Degrees, the unit is already there. If you want to write it in 2SF, should be 59. Alright, so in this one they ask you to find the time that the ball needs to take to go to the maximum height. Distance is not given, otherwise we could have used the s equals to ut plus 1 over 2 at square. But they have done us a favor and they have let us know that we got to use the vertical motion of the ball. So we got to use one of the four equations that we have. The first one being v equals to u plus 80. The second one being s equals to u plus v divided by 2 into t. Third one being s equals to ut plus 1 over 2 at square. And the last one being v square equals to u square plus 2as. But if I consider the first one, I need to find the value of t. Let me see if I have the values. Obviously I have the value of a, which is minus 9.81. Do I have the value of u? Let me check. Do I have the initial vertical velocity? I don't have the initial vertical velocity straight away, but I can find it. So how do I find it? I can find it this way. I can draw two components of this velocity 15. So this component would be 15 times, this one is not connected to the angle. So it should be 15 times sine 60. And 15 times sine 60 would be 12.9, 12.99. So we final vertical velocity would be 0. 0 equals to 12.99 plus minus 9.81 times t. I shift minus 12 on the other side, minus 9.81 times t. These two negative signs would be cancelled out, and t now equals to 12.99 divided by 9.81. So what you get is 1.32. And 3SF you get 1.32. This is how you solve this one. 3 marks, but very easy. And matter of fact, you have to use a single equation, but it is for 3 marks because you need to know the concept of components of vectors.